Okay, so we're going to learn how to differentiate trigonometric functions. There are a few functions that you just have to know. These are the knowledge functions. For example, the derivative of cosine of x is negative sine of x. The derivative of sine of x is cosine of x. You can prove them using the simple limit definition of derivatives. We're going to prove that tangent of x equals secant squared of x. So we know that tangent of x equals sine of x over cosine x. So when we take the derivative of both sides, we get derivative of tangent of x equals the derivative of sine of x over cosine x. So that means that the derivative of tangent of x equals cosine of x times the derivative of sine of x minus sine of x times the derivative of cosine of x all over cosine of x squared. This is using the quotient rule. So we get, when we differentiate, we get cosine of x times cosine of x minus sine of x times minus sine of x all over cosine squared of x. This gives us cosine squared of x plus sine squared of x all over cosine squared of x. And using the trig identities, we know that cosine squared of x plus sine squared of x equals 1. So we get 1 over cosine squared of x, which gives us secant squared of x.
Okay, so here's a problem. Differentiate f of x is equal to cosine of x divided by 1 plus sine x. We're going to start off by applying the quotient rule here. F prime of x is equal to 1 plus sine x times the derivative of cos x minus cos x times the derivative of 1 plus sine x, all divided by 1 plus sine x squared. This is equal to 1 plus sine x times negative sine x minus cosine of x times cosine of x, divided by 1 plus sine x all squared. This is equal to negative sine x minus sine squared x minus cosine squared of x divided by 1 plus sine x squared. Simplifying this, we get negative sine x minus, in parentheses, sine squared x plus cosine squared x, all divided by 1 plus sine x squared. The reason we did this last step here is because then we can use the well-known trigonometric identity, which is sine squared of x plus cosine squared of x is equal to 1. Using this identity, we get negative sine x minus 1 is equal to 1 plus sine x squared. Factoring out a negative 1, we get negative, and then in parentheses 1 plus sine x divided by 1 plus sine x squared, and then we can divide out the 1 plus sine x to get a final answer of the derivative of cosine of x plus divided by 1 plus sine x as negative 1 divided by 1 plus sine x. So now we'll be looking at the derivatives of the inverse trig functions. The derivative of arcsine is 1 over root 1 minus x squared. The derivative of arccosine is negative 1 over root 1 minus x squared. The derivative of arctangent is 1 over 1 plus x squared. Of course, the cosecant, secant, and cotangent all have their corresponding inverse function, which you can see on the screen. Today we will be proving why the derivative of the arctangent is 1 over 1 plus x squared. So we will let y equal the arctangent of x. And to get rid of the inverse trig function, we'll rewrite this as tangent of y is equal to x. We will now use implicit differentiation to get the derivative of tangent of y is equal to the derivative of x. And solving this, we get secant squared of y times dy dx is equal to 1. We can then isolate dy dx and have dy dx equal to 1 over secant squared of y, which is equal to cosine squared of y. So, looking at the triangle on the screen, we see that cosine of y is equal to 1 over 1 plus x squared. Substituting this into the equation for dy, we find that the derivative of the inverse tangent of x is equal to 1 over 1 plus x squared. So let's look at a problem. Differentiate y equals arctan of e to the negative x squared. We'll start off by applying the chain rule twice here. F prime of x is equal to 1 over 1 plus e to the negative x squared times the derivative of e to the negative x squared. Recalling that e to the m in parentheses to the n is equal to e to the mn, we know that f prime of x is equal to 1 over 1 plus e to the negative 2x squared times e to the negative x squared times the derivative of negative x squared. This is equal to 1 over 1 plus e to the negative 2x squared times e to the negative x squared times negative 2x. And simplifying this, we get negative 2x times e to the negative x squared all over 1 plus e to the negative 2x squared is equal to the derivative of arctangent of e to the negative x squared.
So now we're gonna anti-differentiate a trig function. The function we're gonna anti-differentiate is 2x plus 1 all over 1 plus x squared plus x plus 3 all squared. We're gonna do this using the u substitution. So we're gonna replace x squared plus x plus 3 by u, and we're gonna replace 2x plus 1 by du, because 2x plus 1 is the derivative of x squared plus x plus 3. So we're gonna get the integral of du over 1 plus u squared, and we know that this will give us the inverse tangent of u, and then we just have to replace u by x squared plus x plus 3. So the final answer is inverse tangent of x squared plus x plus 3, and we don't have to forget the constant c.